On behalf of all assembled here today, I should now like to invite our newest alumnus, Dr. Thomas Bouchard, to address Convocation.
I'm extremely grateful for this honor from such a distinguished university. I've been influenced by psychologists from Western's illustrious psychology department throughout my career. And in particular, I'd like to mention psychometrician Douglas Jackson and the neuroscientist Doreen Kimura, two giants in psychology and courageous defenders of academic freedom, people I've admired for many, many years. There's a great history here at Western. I well remember my own graduation and the immense amount of work, especially in that physics course, required to reach the goal of graduation. So let me extend my sincere congratulations to you. I still feel that work today. I know you worked hard, and I wish you graduates the very best in your future endeavors. A brief summary of what I have to say might be doing science and finding out how things work. I think that's the goal of science, figuring out how things work. I'm going to give 3 small examples from my research program, but I recognize there are lots of different ways of doing science, so it's not a prescription on how to do anything. First, let me note that the data that I'll talk about to some extent were collected from twins reared apart over a period of 20 years. It took a long time. These twins underwent an entire week of medical and psychological assessment. And the consequences is you need a lot of people to work with you. Over 100 people worked directly on this project, a lot of others indirectly. I didn't accomplish the work by myself. Modern science requires a lot of collaboration. And again, a lot of other people deserve credit. Now, very early in my education, I was strongly influenced by the philosopher of science, Karl Popper. He argued that science is the practice of conjecture and refutations. You come up with ideas, conjectures, and people are going to try to knock them down. That's the way it works. According to Popper, to be considered scientific, conjectures need to be refutable. Popper was trying to solve the dilemma of the demarcation problem. That is, how do you distinguish between science and non-science or pseudoscience? I don't think he solved the problem. In fact, a lot of other people agree with me. It's a very, very difficult problem, and I'll return to that briefly. A number of years after reading Popper, in fact, I was in graduate school, I ran into the following quote: "Science is the belief in the ignorance of experts." We're all ignorant about a lot of things. Ignorance simply means lack of knowledge. We don't know everything. So it's a true statement. The quote is from the distinguished Nobel Prize-winning physicist Richard Feynman. What Feynman meant was that it's important not to believe, and I quote him here, in the infallibility of the greatest teachers of the preceding generation. I love this quote when I saw it because I had some great teachers and I disagreed with many of them. In fact, great teachers should expect nothing less. As you might expect, the goal of the 3 pieces of research I will discuss was to see if I could refute 3 widely held conjectures about human intelligence. And the study of human intelligence at the time I was doing it was quite controversial, as you'll see. Now, these conjectures were well articulated by Stephen Jay Gould. I will use him as a foil. I take it as indisputable that Gould was one of the greatest teachers of my generation. No doubt about it. A very brilliant man, did a lot of brilliant work. But even great teachers can sometimes be wrong. The first conjecture is that there's no general factor of mental ability. Gould put it eloquently and starkly. The general factor is chimerical. Now, the general factor is the theoretical construct that underlies what most people call intelligence or general cognitive ability. No general factor, nothing to talk about. Now, modern psychometric techniques allow us to test this claim with a very high degree of precision. So over 20 years, we collected the data. My research team showed that Gould's claim was false. The general factor derived from 3 different test batteries based on 3 different theories of intelligence, all correlated almost perfectly. They were virtually identical. This work has been replicated by others. We also replicated it using a large sample from the Netherlands, a different country, a different language, different tests. So in our view, Gould's conjecture was refuted. Our proposition, of course, remains refutable. People can go out and do research, show that it's wrong. But we gather a lot of evidence. That's what practicing scientists do, gather evidence. The second conjecture is that the general factor is a reification. Gould specifically argued, and I quote him, "The notion that such a nebulous, socially defined concept as intelligence might be defined as a thing with a locus in the brain and a definite degree of heritability is fallacious." To test this conjecture, I stepped out of my own field of specialization. I examined the relevant animal literature on mice, dogs, cats, cetaceans, primates, even birds. And I discovered an interesting thing. This is a fascinating literature, and there are brilliant people doing things that I had never imagined. 2 laboratories came to my mind. I call them the 2 Louis. I don't know these guys. I don't know whether they know each other. But one is Louis Lefebvre at McGill. He studies birds, and the work is fabulous. The other Louis is Louis Matzel at Rutgers. He studies mice. This is science of the world class, first class. It's really interesting when you step out of your own discipline and run into the work of brilliant people. Part of science and a lot of fun. I concluded a large body of evidence demonstrates that there's a general factor in a wide range of species and in the species studied, it related to brain size and is heritable. I think that work refutes Gould's hypothesis. Clearly, a lot of these animals are not social, but they have a general factor. The third conjecture put forth by Gould, as demonstrated in the previous quote, was that intelligence is not heritable. Our research program was designed specifically to test this hypothesis. Gould, by the way, acknowledged that monozygotic twins reared apart are, and I quote him, "the only really adequate natural experiment for separating genetic from environmental effects in humans." The monozygotic twin reared apart design is very simple. It's 2 experiments. Mother Nature gives us monozygotic twins, 2 copies of the same genotype. Adoption gives us an experiment of society. These 2 individuals are grown up in 2 different environments. It's an extremely powerful experiment because it involves the entire life of the twins. Most research in psychology involves experiments where a person goes in and works in a lab for an hour. Sometimes they're longitudinal and last longer, but this is a lifetime experiment, a very powerful one. We showed that not only is intelligence significantly heritable, so are almost all reliably measured human qualities. We ran our twins through medical laboratories as well, dental laboratories, pulmonary laboratories. So we had all kinds of morphological, physical, and medical measures. These traits were all genetic. Our work on the general factor of intelligence has been replicated by a team of investigators in Sweden, the Swedish study of twins reared apart. I'm proud to say one of my honors undergraduate students at Minnesota was a principal investigator in that study. So one of the things you do as an academic is you produce high quality, well-trained students. That's what you are. And faculty are always proud of such products. Your products, your intellectual products, and you're the most proud product that an academic can create. Just an addition, in addition to studying the twins were apart, we thought we have to replicate. So we created a huge twin registry at the University of Minnesota. That twin registry is still in process, and people are now doing molecular genetic research with the participants in our study. So what I have to do here is acknowledge the cooperation and help of the participants in our study. We had people come from literally all over the world, spend a week being probed, tested, and having dinner with. It was a lot of fun, and we thoroughly enjoyed it. So Gould's conjecture, third conjecture, is clearly refuted. Intelligence, or the general factor, is heritable. What's my message here? It's simple. Feynman was correct. He was telling us that skepticism is an indispensable facet of the scientific mind. He actually went so far in one of his papers to argue that the easiest person to fool and one to be skeptical about is yourself. And he's right about that too. There's a lot of evidence for that. Now, nevertheless, skepticism alone is insufficient. Another great teacher from the preceding generation, Carl Sagan, in a discussion of scientific reasoning, summed up the issue as follows: "It seems to me that what is called for is an exquisite balance between two conflicting needs: the most skeptical scrutiny of all hypotheses that are served up to us, and at the same time, a great openness to new ideas." Now, as you might expect, there's a current psychological theory of openness, and I'm very skeptical, so I'm doing research on it. Nevertheless, Carl Sagan was spot on, and I recommend this scientific attitude be applied to all the claims we're constantly bombarded with in everyday life as well. Thank you for your attention, and again, the very best of luck in your future ventures.